Right, yeah, thanks for having me. So I'm Ryan Reynolds. I'm a systems engineering consultant working for Capgemini Engineering, based over in the UK. Uh, my a little bit of background on myself. I was in mechanical engineering, primarily in kind of naval, marine, um, and moved into a systems role around probably 4 years ago. Um, and through doing a master's degree at Cranfield here in the UK, picked up some interest in AI, and over the last kind of 12 months or so have been looking at trying to implement AI capability into systems engineering. And unfortunately, CAP have got quite a lot of pedigree in the AI domain. So I'm going to be talking little bit today about some of the work that CAP have got going on in the AI space, focusing on how we're using generative or Gen AI, and that being kind of central to our augmented engineering approaches. So I'm going to touch on some of the points on how CAP is using AI to kind of augment and empower its people within the engineering teams. And I'll put a specific focus on systems engineering. So Gen AI, I think, as most people on the call probably have experienced firsthand, it's having a massive impact on all industry at scale. And it's I think it's difficult really sometimes to visualize what that means for us as engineers going forward. A well kind of documented fear of AI is that it's going to start kind of taking jobs from people. You know, is it going to start replacing people? Um, and that question has to be posed to engineers. So, do we think that AI will replace engineers? Perhaps the is no. AI won't replace engineers, but engineers who use AI will replace those who don't. It's this view that has kind of led to a number of initiatives within CAP, including augmented engineering. So, augmented engineering is the application of a hybrid AI approach. So, we combine Gen AI models with other engineering, other AI models to lead a kind of transformation to improve something in some way for clients, whilst trying to enhance and augment CAP's internal skill set. And it's the application of these hybrid AI approaches that we call augmented engineering. And at the center of that, as you can see on the small diagram, is something that we call the generative engine. So the generative engine is central to this Gen AI capability within CAP. It's an internal asset that gives access to pretty much everyone in Capgemini Engineering to a kind of safe, secure, powerful hub for Gen AI technology. It consists of kind of three major aspects. So Studio, which is the first one, and that's just an exploration area. And it just gives everyone within CAP Engineering an area to essentially have a play around, explore, test out different types of AI models. So kind of we've got a whole range of foundational LLMs in there. You can build your RAG databases. There's image generation, and you can just get access to that. You can play around. You can make your own, and just experience what Gen AI can really do for us. The second is collection. So wider Capgemini has got a huge amount of pedigree in the AI space, and we've been working and implementing AI for years. What the collection gives us is an opportunity to see kind of real world applications of some of these kind of transformations that CAP has led using AI, and recently Gen AI. You know, that's been central to a huge amount of things recently, and it just gives a chance to see some of the versatility in the application. The last one is the AI assistants. So these are a range of kind of specialized skill assistants which have all been developed internally to CAP. Typically, they are a kind of LLM foundation model enhanced with a RAG knowledge base, a specific RAG knowledge base. So I've got a list of 4 there: a software engineering assistant, a data and AI assistant, an API assistant, and a systems engineering assistant. So I'll be focusing on this aspect, the AI assistants, for the rest of this presentation, specifically SAM. So SAM, the systems engineering assistant for methods, it is the internal assistant for all of Capgemini's systems engineers, product designers, and it's there to support in the daily work, really, helping to provide a really quite developed knowledge base, and helping understand the kind of system engineering processes, methods, and again, just to help upskill and enhance the engineering, the technical teams. And it's built in a way where it answers in a way to kind of foster learning. When this was being developed, there were 3 kind of main knowledge areas that needed to be managed. So firstly, we had the kind of methods, the processes, that industry agnostic area of systems engineering. So standards, central knowledge base, all of that. The second is a kind of industry specific client focus. And thirdly was a project focus, project capitalization. So currently, SAM is working firmly in the process and methods, the industry agnostic data set. So SAM was built in the generative engine. So it's based on the Claude 3.5 as the foundation LLM. We've got a RAG database of over 1,000 documents. We've got all sorts of sources in there. So all cap is licensed with all of these bodies. So we've got INCOSE, we've got the System Engineering Handbook, we've got ISO standards, we've got kind of open source, well-established data sources for systems engineering, so things like NASA System Engineering Handbook, the System Engineer body of knowledge, and then we've got some other kind of training materials that Capgemini's developed itself, and some other kind of open source. So it's got a really quite versatile data set. There's been some kind of preliminary testing done with SAM. So some of the results found that SAM formed better on specialist questions than just the basic LLM. The foundation model itself achieved about 80% correct. SAM, with the enhancement of the RAG database, was able to get that level up to about 95%. And we've had some kind of really basic testing in my unit as well, where we've done some testing on the INCOSE SEP, the questions for the kind of ASEP and CSEP qualifications. And on a sample of about 870 odd questions, SAM answered about 86% correct. So it's shown itself to have it proved itself to be a really knowledgeable tool. And there are obviously concerns about the kind of copyright, because this is internal. It's, you know, that's where we're able to use that. So I've got a couple of use cases here to run through just to show how SAM works. So 3 different systems. I don't think I'll be able to show the first video in full just because of the time constraints. But what it aims to show is how you can use SAM from a very, very basic prompt to support in defining activities, and using it in partnership with other tools, not related to SAM. The example I use in the video is something called Plant UML. And what we aim to do really is ask SAM to provide you know, from starting from scratch, how can we answer certain questions. So what I'm asking you here, sorry if the text is very small. I'm using the example of a camper van. This was a case study we were playing around with at a previous conference, and I'm asking it here, what process, if I wanted to design a camper van using a systems engineering process, what should I do? And it's essentially laying out step by step. I end up asking this video to focus on certain aspects of the functionality that the tool itself identified and captured. Generate code that I can use in Plant UML, and that can then represent this. Now, these aren't models as we would know them in an MBSE approach. This is a diagram, but what it does help you is to start. It gives you a starting point to build upon, which can be a really challenging point anyway. Some other case studies, very generic. The prompt here is, can you generate a SEMP template? No additional information, and it captures some of the key aspects you would expect to see in a system engineering management plan. So systems approaches, organizational responsibilities, technical processes for kind of requirements, design development, gives you kind of system engineering management governance, and captures some information around technical reviews. And then it references where it is getting that information. So that's in an attempt to show that it is referencing and not just hallucinating and making the answer up. In this case, it's using the NASA's System Engineering Handbook as the primary source. What it allows you to do here is, up to the user at the time, but you're able to kind of dive into each of these and ask for elaboration, and build from there. So that's kind of what I attempt to do with the last one, which is PDR criteria. So taking the example from the previous one, and the kind of governance aspect, technical reviews. This was at the tail end of a kind of other use case of this. So I asked, what would the typical acceptance criteria for a camper van be during a PDR? And again, Sam's able to outline some kind of key aspects you would typically expect to see: requirements compliance, design covers all requirements, and the traceabilities all there, all available. Design maturity, kind of all the subsystems being defined with kind of 3D models or detailed drawings. Technical feasibility, so major technical risks identified and have mitigation strategies, and interfaces identified and control documents drafted. So it gives quite a comprehensive review. And again, you can then kind of dig down into this further and ask for elaboration. So that's kind of where we are with SAM at the moment. We're industry agnostic, although there is some, this using the camper van example, there are some sources within the RAG database at the moment that can provide some industry specifics, but it's not for that specific industry. It's very, very open. And it's a very powerful tool. So there's kind of two main areas now for development, the next steps. Firstly is current scope improvements. So continually review this with the subject matter experts, make sure it isn't making things up. Probably all aware that that's a risk with these Gen AI systems. Just increase the RAG database again, improve the capability of the tool, consider diagrams, and then looking at deploying it in its current state onto programs and projects. The second kind of key area is expanding the scope. So showed this figure earlier on, we're focused on the process methods, industry agnostic. So it will be improving, extending that scope of SAM to cover kind of industry specifics, client specifics, and then future into kind of project capitalization, getting SAM as an asset onto projects. How do we build it into plans, and how do you start seeing some kind of tangible improvements. So that's everything from me at the moment. Thank you very much.